It was August of 1944, somewhere on the outskirts of a village in Normandy, whose name most Americans never learned to pronounce. A German panzer commander climbed down from his immobilized Tiger, his uniform still smelling of cordite, his hands trembling from the concussive blast that had finally stopped his engine. He had fought from Tunisia to this hedgerow country. He had destroyed more Allied tanks than he could count from memory. He had watched his crews burn and walked away from ambushes that should have killed him. But the thing that broke him, the thing he would describe to Allied interrogators 3 days later, with something between bafflement and fury, was not the artillery, not the fighter bombers, and not the American infantry he had spent years dismissing as amateurs. It was what he had watched through his commander's periscope in the early hours of that same morning, 2 weeks before his own tank finally died. A column of American Shermans he had helped destroy the day before had reappeared. Not different tanks, the same ones. He recognized the damage patterns on their hulls. American mechanics had worked through the night in a muddy field under camouflage netting, pulled the engines, replaced the parts, and sent the vehicles back to the front line before dawn. In Germany, those tanks would have been towed to a rear area depot and waited weeks for factory components. He told his interrogator that it was then, watching those repaired Shermans roll forward in the grey morning light, that he understood for the first time that Germany could not win this war. The misjudgment began long before the first Sherman ever crossed the Atlantic. German military culture had spent decades building an engineering tradition that the world genuinely admired. The factories of the Reich produced some of the most sophisticated weapon systems ever conceived. The Tiger tank mounted an 88mm gun derived from the legendary anti-aircraft weapon that could destroy any Allied tank on Earth at ranges exceeding 2 kilometers. The Panther carried frontal armor so steeply sloped that standard Allied rounds simply deflected off it at normal combat distances. German optics were among the finest in the world. German rangefinders, German crews, German gunnery standards. All of it was real, and none of it was propaganda. When Allied tank commanders described German armor, they used words like terrifying. American crews who survived Tiger engagements talked about it the way men talk about surviving a natural disaster rather than a battle. Nazi leadership shared this confidence in German industrial supremacy and extended it into open contempt for American capabilities. Hermann Göring, head of the Luftwaffe and one of Hitler's most trusted confidants, dismissed American industrial claims as fantasy when President Franklin Roosevelt announced in May of 1940 that the United States would produce 50,000 aircraft per year. The previous year, American military aircraft production had totaled fewer than 3,000 planes. Göring considered the promise a propaganda statement from a country that made automobiles and refrigerators, not weapons of war. His characterization of American industrial output as fit only for razor blades became infamous among senior German officers and was repeated in headquarters messes from Berlin to Tunis. Hitler himself told his inner circle in January of 1942, weeks after Pearl Harbor drew America into the war, that he did not see much future for the Americans. It was, he said, a decayed country, corrupted by racial problems and social inequality, incapable of sustained military effort, what German leaders failed to understand, and what American engineers in Detroit and Lima and San Jose had been quietly building for years, was that the question of which tank was the best on a test range was entirely separate from the question of which tank would win the war. The Sherman was not the most powerful tank in France. It was not the most heavily armored. In any controlled engagement against a Tiger or Panther at long range, with both crews of equal skill, the Sherman would almost certainly lose. German engineers who examined captured Shermans at the Kummersdorf, proving ground in 1943, documented this with clinical precision. They measured every armor plate, calculated penetration values at combat ranges, photographed every system, and confirmed what their tactical experience had already suggested. The American tank was outmatched in the categories that German engineering culture valued most. But the German engineers were measuring the wrong things. They counted armor thickness and gun caliber. They did not count floor space in the Detroit tank arsenal, which had been farmland in 1940, and by 1942 was the largest tank factory in the world, covering more than 1 million square feet of production floor, operating 3 shifts a day, 7 days a week. They calculated penetration values at various angles. They did not calculate what happened when a damaged Sherman was recovered from the battlefield, driven to a field maintenance area 2 kilometers behind the lines, and returned to its unit within 18 hours using standardized parts that arrived by truck from a supply depot that had received them from a ship that had crossed the Atlantic from a factory that had never once stopped its assembly lines. The German analysis produced technically accurate conclusions and strategically catastrophic ones. The production gap was not gradual. It was absolute, and it was widening every month the war continued. American factories produced 49,324 Sherman tanks between 1942 and 1945. 11 different manufacturing facilities contributed to this total, each applying mass production techniques refined over decades of building automobiles for the largest consumer market on Earth. The Chrysler Detroit tank arsenal alone accounted for nearly 18,000 vehicles. Total Tiger I production from August of 1942 through August of 1944 amounted to approximately 1,350 tanks, all from a single Henschel factory in Kassel. For every Tiger that Germany built, American factories produced 37 Shermans. For every Panther, 8 Shermans. The arithmetic was not merely unfavorable for Germany, it was a verdict. The reliability gap compounded the production gap in ways that German commanders found genuinely demoralizing. The Panther made its combat debut at the Battle of Kursk in July of 1943, the largest tank battle in history. German commanders had rushed the new vehicle into service despite repeated warnings from engineers that production models required further testing. The High Command wanted Panthers at Kursk. They got Panthers at Kursk. Before the first tank encountered an enemy, contemporary German reports recorded that 50% of vehicles were inoperative. The failures involved engines, transmissions, and final drives. Panthers were breaking down on the road march to the battlefield. Within a week of combat, more than 180 Panthers had been reduced to approximately 40 functional vehicles. The most technologically advanced tank in the German arsenal carried an operational readiness rate just above 16%. The Sherman, under comparable conditions in comparable theaters, achieved readiness rates approaching 85%. The maintenance culture that produced these different outcomes was not accidental. American designers had built the Sherman with the assumption that it would break down, that it would be damaged, and that it needed to be returned to service quickly by soldiers working in fields and orchards and bombed-out barns with basic tools and no cranes. The transmission and final drive assembly bolted to the front hull in a configuration that a field maintenance crew could extract without specialized equipment, swap for a replacement drawn from standardized inventory, and return to service in hours. German tank design treated maintenance as an engineering afterthought. The Panther's transmission was buried deep in the hull, accessible only through cramped interior passages after the turret had been removed and the engine extracted. Replacing it required a workshop, specialized equipment, trained factory mechanics, and weeks of time that the Army rarely had. Tigers were worse. Many were abandoned, not because enemy fire destroyed them, but because routine component failures could not be repaired before advancing. Allied forces overran their positions. The strategic consequences cascaded through every level of German armored operations. A meeting of the Panzer Commission on January the 23rd of 1945 documented the scope of the crisis in terms that would have seemed unimaginable to the men who had designed these vehicles. The assembled officers reported 370 defective Panther final drives awaiting repair or replacement, 500 defective Panther overdrive units that had failed before a planned eastern offensive could begin, roughly 100 Tiger failures of various types. These were not vehicles destroyed by enemy fire. They were vehicles that could not start, could not move, could not fight, because components that should have been engineered for field replacement required factory-level restoration that German industry could no longer provide. General Tommele stated at that meeting that an orderly utilization of tanks was simply impossible under these conditions. The troops, he said, lose their confidence and in some situations abandon the whole vehicle just because of this problem. American crews were having a different experience. When a Sherman threw a track or blew a transmission, the crew called up on their radio. Parts arrived. The vehicle went back into action. The radio itself was part of the asymmetry. American tanks and infantry operated FM radios, frequency modulation sets developed from technology that Edwin Howard Armstrong had patented in 1933 and that the Signal Corps had standardized across the entire military by 1940. FM radio cut through the electrical interference of tank engines and artillery explosions, delivering clear voice communication regardless of battlefield conditions. German radios used amplitude modulation. In the electromagnetic chaos of a tank battle, German AM sets drowned in static. American crews could speak to their commanders, to their artillery forward observers, to their maintenance units, while the battle was still happening. German crews sent runners. German mechanics drove forward in the dark, hoping to find the right vehicle at the right location. American logistics operated in real time because American communications made real-time coordination possible. The Battle of Aracourt in September of 1944 brought all of these factors into the most direct possible confrontation. The German 5th Panzer Army committed 262 tanks and assault guns to a counterattack in the Lorraine region of France, including 107 Panthers. American Combat Command A of the 4th Armored Division, equipped with Shermans and tank destroyers, waited for them. The engagement lasted 11 days. When it ended, German forces had lost 86 tanks, confirmed destroyed, and 114 damaged or broken down. Only 62 of the original 262 vehicles remained operational. American losses totaled 25 tanks and 7 tank destroyers. Military historians studying Aracourt have noted that the Panther was superior to the Sherman by every specification the Germans valued: better gun, better armor, better optics at long range. None of it mattered when undertrained German crews in mechanically unreliable vehicles were met by experienced American tankers who understood their machines and knew how to use terrain, speed of turret traverse, and concentrated artillery to compensate for every disadvantage they carried on paper. Field Marshal Erwin Rommel, who had handed American forces their worst defeat of the European War at Kasserine Pass in February of 1943, and had initially concluded that his low opinion of American military capability was confirmed, revised that judgment with striking speed. In Tunisia, he wrote afterward, "The Americans had to pay a stiff price for their experience, but it brought rich dividends. Even at that time, the American generals showed themselves to be very advanced in the tactical handling of their forces. The same army that had broken and run at Kasserine Pass became, within 18 months, the force that shattered German defences across France in a campaign Rommel himself called astonishing. His revised assessment of American soldiers described men who immediately returned fire, who brought punishing artillery or air power onto whatever they were fighting, and who moved to counterattack as soon as the fires lifted. What Americans lacked in tactical refinement, veteran German observers concluded, they more than compensated for in something that defied easy categorization: a willingness to absorb punishment, recalibrate under fire, and return to the attack without the hesitation that characterized more cautious opponents. The German soldiers who said the same thing about American mechanics were describing something that went deeper than maintenance procedures or spare parts inventories. They were describing an entire civilization's relationship to production, to problem solving, to the assumption that if something was broken, it could and would be fixed. American soldiers had grown up in a country where automobiles were mass-produced, where replacement parts were available in every town, where a broken machine was a solvable problem rather than a crisis requiring factory intervention. They brought those assumptions to war. German soldiers had grown up in a culture that treated engineering excellence as a form of national identity, where complexity was proof of quality, and where the finest weapon was by definition the most sophisticated one. They brought those assumptions to war as well. The assumptions that worked were not the ones that looked most impressive on a specification sheet. Albert Speer, Hitler's Minister of Armaments, and the man most responsible for the dramatic expansion of German war production after 1942, acknowledged the Sherman's capabilities in his post-war memoir with a candor that would have been unthinkable during the war itself. The Sherman climbs mountains, he wrote, that our tank experts consider inaccessible to tanks. Its cross-country mobility on level ground is, as the 26th Panzer Division reported, definitely superior to that of our tanks. This was a remarkable admission from the architect of German rearmament. German tank experts had designed vehicles to destroy other vehicles in direct combat. They had not designed vehicles that could keep pace with an opponent across the varied terrain of a continental war, recover from mechanical failure in a muddy field overnight, and be waiting, repaired and reloaded, when the next battle began. The German panzer commander captured in August of 1944 spent the rest of the war in Allied custody. The records do not preserve his name or what he did after Germany surrendered, but the thing he told his interrogators about watching repaired Sherman's roll forward in the morning light was not an isolated observation. It was recorded because dozens of German prisoners said versions of the same thing. Some talked about the artillery, some talked about the fighter bombers, some talked about the logistics convoys that stretched back to the beaches and never seemed to run dry. But the ones who had faced American armor described, again and again, the experience of destroying American tanks in the evening and finding those same tanks, or tanks exactly like them, in front of their positions the next day. Some described it with professional frustration. Some described it with exhaustion. Some described it, by the final months of the war, with something that sounded like despair. They understood, in the end, what the German High Command had refused to understand in the beginning. The war was not going to be decided by which nation built the most formidable individual weapon. It was going to be decided by which nation could build, ship, supply, maintain, and replace weapons faster than the other side could destroy them. Germany built the finest tanks and lost the war. America built adequate tanks in quantities that defied German comprehension, kept them running with mechanics who worked through the night in farm fields and replaced every loss before the next morning. The panzer commander watching those repaired Shermans advance at dawn was watching not just a failed ambush, he was watching the outcome of the war announce itself, one recovered vehicle at a time, before a single shot had been fired that day. If you were a tanker in 1944, would you rather fight in a Tiger or a Sherman? Tell me in the comments. Please like and subscribe.